Good evening, everybody. Welcome to the main May meeting for the Triangle Area SQL Server Users Group. Couple of things. First, promo cam. So I'm actually showing myself on camera again 2 days in a row. It's kind of weird. I may hold up a newspaper just so you know that it's the current day. But then I'd have to get a newspaper, and I don't even know where to get those anymore. What are newspapers? Never heard of them. I am very pleased that I'm able to say welcome to Research Triangle Analysts viewers. The Research Triangle Analysts group is another excellent group in the Triangle area that is, in their case, they're specifically dedicated toward the data science, statistics, and mathematics side of the world. So I'm dropping in chat a link to their meetup group. Highly recommend you go over there, check out their stuff. They have some outstanding presentations. Unfortunately, there's sometimes a little conflict in terms of what day. Oh no, you can't hear me. So let's call a mulligan on the beginning here. Is anybody else able to actually hear me, or is everybody just seeing my mouth move and just can't put any words to it? All right, let's try now. Oh, we have somebody who can hear. Okay, so it may just be your audio, the Duke, because there are people who can both see and hear me. They have confirmed my existence, and I'm as a solipsist, I'm happy for that. Okay, so going back to what I was saying, welcome Research Triangle Analyst users, members, people who enjoy the group. Very glad to have you here tonight. I do want to send out a couple of announcements for RTA. One of them is for Analytics Forward 2020. It has been postponed for now, but they are working on getting a date for that. Analytics Forward is an outstanding unconference where you don't necessarily know what's going to happen. It's a fun event to be at. It's a fun event to present at. A little bit of a challenge because you'll come in with ideas and try to see what's the schedule going to look like. Regardless of how the schedule looks, it's a really good event. Been to a couple of them, presented at one of them. Hopefully I'll be able to make it this year. Depends on schedule. Also, RTP has a Slack channel. So I want to drop that link in chat as well. rtpanalysts.slack.com. And go there, join them, check it out. If you're into Slack, definitely check that out. Data Architecture Day was this past Saturday, and we have the YouTube playlist up, so I wanted to post that link here. So that's in chat as well. That link will get you to all of the 11 videos from Data Architecture Day. It was 13 hours worth of sessions all about architecture on different platforms, whether that be transactional databases or warehouses or MongoDB or Elasticsearch. A lot of different topics, great mix of speakers, so you'll have a lot of fun going back through those videos. Last announcement I want to make today is that there will be no shop talk this upcoming Monday. So I'm going to take Memorial Day off, and without me around, the whole thing falls apart, mostly because I'm the one with the recording system. So there won't be any shop talk on Monday, but there will be the following Monday. So we'll make up for it by doing exactly the same thing that we always do. So with that, I want to switch over to the topic for tonight. We are going to talk about developing a solution using SQL Server's machine learning services. Mark Hutchinson also calls out Indie Week, which is, I'm not sure what the dates are for that. Mark, if you drop that in chat, I'll do an announcement on that as well. But machine learning services. My name is Kevin Fiesel. I run a predictive analytics team. I'm here in Durham, North Carolina. I'm a Microsoft Data Platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is that I want to try to find and link to 5 to 10 interesting posts per day on topics like database administration or development, R, Python, Hadoop, Scala, Spark, Power BI, reporting services, security, or anything else in that broad data platform space That's curatedsql.com. So what is machine learning services? Well, ML services was originally released in SQL Server 2016 as SQL Server R services. It is the ability to interact with external languages, starting with R, and then in 2017, they added external Python support. And then they renamed the product to Machine Learning Services because it was no longer just R. With SQL Server 2019, Microsoft has added Java support and has opened the door to other languages too. So I would expect to see additional languages come in. Java there also does mean Scala, basically anything on the JVM. So what I want to do in this talk is give you an idea of what ML services is, where it might be a fit for you. Then we'll look at installation and configuration so that you have an idea of how to get this thing on your machine. But the majority of the talk is going to be focused on the development side. It's going to be external script execution, and then we'll build a fairly simplistic, but I think interesting project, and then deploy some custom R code. We'll also play around with some Python code. I didn't get the Python project created in time, but I'll talk you through the process. So let's start with an overview. If there are any questions throughout this, drop them in chat. I've got chat right in front of my face, which is not always a good thing, but it's a thing. So you have questions, drop them in. I'll bring them in over the course of my discussion here. So let's get an overview of machine learning services. Here's a rough diagram of how it works. This is from Microsoft, and what it's telling us, very simply, is that we have SQL Server running over in its own process. So it lives in its own contained space. The Launchpad service is a separate executable, and that's going to reach out via a DLL to our terminal. So what that's saying is R is not inside SQL Server. It is launched from SQL Server. And within the R terminal, you do whatever things you expect to do in R. And there are ways to get back into SQL Server. So we can send data into R, we can retrieve data back from R, and have it be somewhat transparent. I have to say somewhat because there are still some difficulties. The Duke has a question for the end, and it is a good question. The answer is still teeth grating, but less tooth grating, and the tooth gratingness is probably in more advanced cases. So in 2017, introduced Python. Here's the image for Python. It's totally different because it's yellow instead of blue. So other than that, you've got some changes. Obviously, it's calling to Python's executable instead of rterm, but still, it's the same rough idea. They took the same core mechanics and iterated on it. Java integration is a bit different from this. Other languages, as they'll extend out in the future, will probably be different from this, but this is how R and Python both work. Native scoring is actually one of the really cool things about ML services. And I'm going to bounce up and down here because I am going to obstruct the slide. So SQL Server has some C++ implementations of a few algorithms, and I've got them listed here. These are in a couple of libraries. For R, it's called RevoScaleR. For Python, RevoScalePy. And if you use one of these 5 algorithms, not just say the RLM method to create a linear model, not just that. You have to use RevoScaleR's RxLenMod or RevoScalePy's Rx_len_mod. If you use those, then you can perform native scoring. What that means is that predictions don't require you to load the service, the rterm or Python executable, through the Launchpad. It stays within SQL Server. It runs a DLL that is installed with SQL Server. And even better, It doesn't even have to have machine learning services installed. If you have a model saved as var binary in the database, and it's using one of these algorithms, we can use native scoring predict function to generate predictions on a transactional system that doesn't have any training happening at all. These predictions are also really fast. Like my specific scenario is roughly 100,000 records, 100,000 predictions generated per second, which is a pretty good number as far as I'm concerned. But again, you're limited to these algorithms. So there's a fairly tight number of things that you can do. If you want to go outside of that, you can use any other algorithm. But prediction now involves calling back out to that launchpad, running your R or Python, and waiting for it to return, which actually is what we'll do tonight. We're not going to use any of these tonight. I'm not going to show you native scoring. I am going to post a video on YouTube probably tomorrow, and that video shows native scoring, gives you an idea of what you can do with it and how it works. So I'll link to it in the link that I'll give you at the end for the slides, but that won't be up until tomorrow. So the upshot, machine learning services is going to bring machine learning code to the data, because typically, the amount of network transfer involved in moving code over is pretty slight. The amount of network transfer involved in moving a lot of data over, usually pretty intense. So ways that we can remove data movement will help us out in the end. It's one of the things that we learned from Hadoop and from that big data movement, that taking code to data typically works better for us in the long run. This also will extend functionality inside SQL Server. There are things that you could only have done with CLR, the Common Language Runtime, like a fast way of getting a median for a lot of rows, or interaction in various ways, calling out to web services, or some of the more complicated statistical methods. You had to call out to .NET code in the past if you wanted to keep that within SQL Server. Now, you can shell out to R or to Python, have it do the work, and then bring it back. So it's pretty nice that way. We can also use Resource Governor to limit CPU and memory utilization so that you don't necessarily kill a box. I have a whole talk on production for machine learning services that is different from this one. This is development. If you're interested in the production side, here's the link to the production version of the talk. There's a lot of overlap, but there's quite a bit that will be different, including actually learning how to use Resource Governor in this. So what works well? Well, I think that there are a few scenarios that work really well with machine learning services. And the key is that you have at least one or two of these requirements. You really want to have that input data already in SQL Server. If your input data doesn't live in SQL Server, and you can't use something like Polybase to virtually extend it to SQL Server, it's probably not going to make much sense. Just have remote R code or Python code go grab the data and do the work on cheaper boxes somewhere else. But if you have the data living in SQL Server, that's a plus. It's a good potential scenario. If you're willing to work with batch training, batch predictions, batch scoring, then you're going to have more success with machine learning services. There is a spin up time. The time to get the launchpad going can be anywhere from, say, a second to 5 or 10 seconds. And I don't have a hard answer for why it takes as long as it does when it does, but I usually just build in, look, there's going to be about a 3 to 6 second wait time just to get the service started. That's before you run any R code or any Python code. So if you need something essentially in real time, unless you can use native scoring, this won't work. If you can use native scoring, you will get real time. You will get a result back so fast that it's like it didn't even do anything. So if you are able to use the native scoring algorithms and the predict operator, it will be fast. Really, really fast. That's totally worth it if you're able to get away with it. So is that 3 to 6 second overhead per call or up front? It is when you start up the Launchpad for a session. So I shouldn't even say for a session, I should say for a batch, because yeah, it'll be 3 to 6 seconds, and that's to start up the Launchpad for every call of SP execute external script. So if you have 3 separate sessions doing it, they all take that overhead. If you have one session that calls batch after batch after batch, every call to that will start up the Launchpad, will have that overhead. Hopefully that was sufficiently unclear. Ironically, if you want to interact with .NET code in R, there is a package, r.net. When I tried it out, a couple times I've tried it out, I've not been very happy with it. I actually prefer going through SQL Server for this. There's a lot of code that makes it easy to have .NET interact with SQL Server. And there's this process which makes it pretty easy to have SQL Server interact with R. But it's really not easy to have R interop with .NET. It's kind of a messy package. It doesn't necessarily work all the time. And this actually works better. If you're willing to dump tens of thousands of dollars per core in terms of licensing, you can get interop. That doesn't seem like the best use of a lot of money, but again, you've already got your data in SQL Server. It's not a bad plan. Now, when does this fall apart? Well, think of the opposite scenarios. If I need essentially near real-time individual predictions and I cannot use native scoring, this is not going to work at all for me. If none of your core data is in SQL Server and you can't virtualize it with Polybase, it really doesn't make sense. You're taking data from other sources to dump it in here just to interact with it, when R and Python are perfectly good at taking data from a bunch of different sources and interacting with them. And if you already have heavily loaded CPUs on your OLTP systems, please don't use ML services. It will tip your services over. Your systems, this can be very CPU intensive. I mean, of course, it depends on the code that you're writing. It depends on the work that you're doing. We will do some neural network training on our production servers, and that puts CPU pretty high because we're not using GPUs. Now, granted, this is not extremely large amounts of data per trained model, just enough that it takes some time and it takes a lot of CPU. So we could spike our CPU at 100% just from machine learning services. If you have a busy SQL Server already, combining it with this is a good way to have something collapse. Security concerns about machine learning services. So that is more aimed at my production talk. I will see what I can do talking about it at the end. I've got your comment saved here, so I will get back to it as a question at the end. All right, quick note. Azure SQL Database Edge. So this is a version of SQL Server that is intended for IoT scenarios. This is what you would put on a fleet of Raspberry Pis or a whole bunch of ARM devices, say, that you put in tractors, that you put in vehicles. This supports ONNX, the Open Neural Network Exchange, and allows you to perform predict functions using neural networks. So this is an extension of what the predict operator is allowed to do. I'm really excited about this. I'm excited about Azure SQL Database Edge to begin with. I'm really excited about this ONNX support. It is not in the box product, SQL Server 2019. It is not in any normal version of SQL Server right now. Hopefully it extends out to the rest of the SQL Server space, but they're focusing on SQL Database Edge for ONNX at the moment. However, this opens up new possibilities of native scoring for neural networks, which would be a real coup for Microsoft, I think, because you train your neural network, and if you get near real-time predictions out of it from SQL Server, that definitely opens up the number of models that you can get that native scoring on. So it's a very exciting technology, both Onyx and SQL Database Edge. Very exciting technologies. So Eric Yount mentions that you need a link to join the RTA Slack and includes it in the chat here. So if you want to join RTA Slack, there's a link in chat for you. I will try to take a copy of that so that when I post this video, people will have an idea of what I'm talking about. So thank you, Eric, for the link. Let's talk about installing machine learning services. This will be brief. I'm not going to install it because it does take a little while. But as far as we're concerned, I click a link, like new SQL Server standalone installation or add features. Now, we have two choices, the good choice and the bad choice. The good choice is in a box. Machine learning services in database. That allows you to install R and Python as interop with SQL Server. The bad choice, which, okay, is not actually bad, but typically not the choice you want to make, is machine learning server standalone. So ML Server standalone does not have that SQL Server integration. It is just an installation of Microsoft's machine learning server with R DLLs or with Python DLLs. Generally, you're going to want to select the machine learning services in database. There are few reasons why you'd want standalone. They exist, but typically, if you're listening to this talk, you probably want in database. So you select that, next, install. And the next thing that's related to ML services is that we have to enable external scripts. So we do that using spconfigure, turn on external scripts, and reconfigure Go. And this is a Microsoft product, so you have to restart it. We have to restart the Launchpad service and the SQL Server database engine. After restarting both of those, ML services should be up and running for you. So that's the easy part. Installation is pretty easy for this. Upgrading, a little more complex. That's in the production talk. So let's talk next about installing packages. I have a fresh version of SQL Server. It has a slightly old version of R and a slightly old version of Python. And I want to install packages on it. Well, there are at least a half dozen techniques that I know of for installing packages for R and for Python. I'm going to cover what I consider the three best approaches, especially from the perspective of you having installed SQL Server 2019. If you're on 2017, some of this is about the same. If you're on 2016, the world is totally different. So I'm assuming you got 2019 Developer Edition or you've got it in production someplace. The general best approach is to use a tool called sqlmlutils. This is something that Microsoft develops and maintains and allows you to install R and Python code remotely. Meaning, I have a SQL Server on some machine, some server. I can connect to it from my desktop or from a build server and install a package remotely. So I don't have to be connected into, like RDP'd into the server. I don't have to SSH into the server. I don't have to directly connect to it myself. mlutils will connect to the remote SQL server, will manage that installation of the package, and will set up all of the conditions within the SQL Server database to support our machine learning services. This works in SQL Server 2019 with both R and Python. If you have SQL Server 2017, only works with R. They changed the way that the security model works in 2019, and that led to a few knockoff changes. One of them was a positive here that Python kind of followed the same process as R, which was a good thing here because it allowed a tool like mlutils to work. Now, if you want, you can simply connect to the remote machine and run a console, either the R console or the Python executable. The specific executable that you have to run is in your SQL Server installation. So MSSQL 15 dot instance name, and then R services bin, or for Python, MSSQL 15 dot instance name, Python services scripts. Look for the executables that you need inside there. If you have other versions of R and Python on that machine, those aren't the same as what we'll use for ML services. Question is this session going to be recorded? Yes, it will be recorded. It'll show up on YouTube. I'll probably post it tomorrow or Thursday, depending on how busy I am. But definitely being recorded. So all of the terrible things that I say, sadly, will be known throughout history. Last method, creating an external library. This is going to require grant alter any external library. And what that allows you to do is create a new library in SQL Server. Like in this case, I'm installing the Benford analysis package in R from a local drive. You can select the content, so the file name, you can select the language, and this will install either as the database owner or as yourself, depending on permissions. The difference here is the database owner is going to be able to essentially allow everybody to use those packages. So if I install it under the database owner's name, everybody gets to use that package or that version of that package. If I install it privately, using my account, only I can access it. So that's the key difference. If I want everybody to be able to use this version of Benford analysis, I need DBO rights, which, by the way, is pretty heavy security to give to a person to be able to install a package. Now, if I'm willing just to make it so that only I can run the code, then I don't need anything other than grant alter any external library. So that's kind of your trade-off, I guess. Of these three, I would say if you're using 2019 or if you're installing an R package in 2017, start with sqlmlutils. Try to use that. If it works, great. There are cases where it doesn't work. I actually have a bug out right now where I have an R package that it contains a model that is about 60 megabytes of a neural network. And for some reason, sqlmlutils just does not want to install that package. If I take out that model, I have a much smaller install, and it installs the package just fine. I have an open bug on that. Hopefully it gets resolved at some point. In the meantime, what I'm doing is I copy that binary package up to the server, and then I run create external library. For complex packages, like if you want to install Keras in R, there are a few steps that are involved and some possible interactivity required. I've had to use the R console instead of sqlmlutils to install Keras for R on machine learning services. I've only had to do this with Keras. I haven't had to do it with any other packages. Interestingly enough, TensorFlow installs just fine. It's just Keras that's choking. But just keep it in mind that there are a few different ways to reach these packages. So let's hop into a demo where I'm going to show you sqlmlutils for R and for Python. So let's start by going into R. And what I have is RStudio. I've got the sqlmlutils script right here. If you want to install sqlmlutils, you're going to need two things. First thing is our ODBC extensions. So if we don't have that, we're going to install it. Second thing is the sqlmlutils library itself. So our ODBC extensions is on CRAN. I'm just pulling from Microsoft's CRAN. You can certainly pull from others. So Duke University has a CRAN repo that I tend to pull from because it's very close to where I am. But get your local CRAN repo and it'll work. Then install packages for mlutils is a little different because this is not in CRAN. So I've got the actual source file, sqlmlutils071.tar.gzip. If they upgrade this version, then obviously I'd have to change the script. And I set repos equals null so that I tell it, you're not going to a CRAN repo. You're just doing your own thing. CRAN, I am from the Midwest. It is my duty to avoid as many vowels as possible. So crayon, actually I would still say crayon, but I guess you get live long enough down here, it can become a crayon. All right. So both of these are already installed because I've actually done all the prep work for this. Next step, I'm going to use sqlmlutils connection info and connect using my ODBC 17 driver for SQL Server. So I've already got that driver installed. I can go to ODBC data sources. It's probably in 64-bit. I can come back over here, look at my drivers, and I have an ODBC driver 17 for SQL Server. You probably do as well. If you don't, you can always get it. Or you could use one of the other ones. So server is localhost, database is expense reports. I'm going to connect using Windows authentication. You could, of course, also connect with SQL authentication. You just set the UID and password. Then if we want to install a package, in R, we have a function called install.packages. sqlmlutils says, well, let's just say SQL install.packages. Connection string will be whatever we connect it to. We have our package, or we could have a list of packages. The scope, public or private, is what I was talking about with whose account are you installing it under. Are you installing it publicly, where everybody is allowed to use the tidyverse? Or are you installing it privately, where you are allowed to use this installation of the tidyverse? So that's all up to you. You can install a single package, and I've already installed tidyverse because this takes a minute. It is 86 separate packages that get installed. So even on a good day, usually takes 3 to 4 minutes, and I didn't necessarily want to spend all of that time waiting for it to install. So it's just going to check and find out that everything's already installed. In the meantime, got a question. Saw a presentation 2 years ago using SQL Server from R, Python, Jupyter Notebooks, R Notebooks, etc. This is SQL Server to R or Python code. Can you discuss the benefits or detriments over working from the development side? Yes, I can, and you'll see some of the benefits and also some of the pains as we go through the course of our demos. The simple thing is that this is encapsulating R and Python code within SQL Server. So if you have a robust environment where SQL Server is heavily used for data access, and you've got, say, a lot of .NET code or a lot of Java code, you're going to probably find that this will be quite helpful because you don't have to worry about the R or Python behind the scenes. Now, if you don't have this robust environment with SQL Server, you may instead prefer to have R and Python live externally and maybe spin up web services using GUnicorn or something else and expose your data that way. If I want to install multiple packages, I can run through this. And by the way, these are rerunnable, obviously. If it determines that the package is already installed, basically just says, oh, it's already installed. If we want to remove a package, there is a remove.packages. And I could remove zoo and WKB, except I have other packages that depend on zoo, so it won't actually remove them. Or it won't remove zoo. It will remove WKB, though. So I won't do that. Instead, what I will do is look at the installed packages list. And this will take a moment. You'll notice it is taking some time to query SQL Server and have everything up and running. This is a little bit slower than it normally would be, but we're not generally talking about something that happens instantaneously. The plus side is This is the type of thing that you do once in a while as opposed to all of the time. So if it takes an extra 10 seconds, if you do it as part of a build process, I don't know, it's not that terrible. Even if you do it locally, it's 10 more seconds to surf the internet. So what I'm looking at is the list of installed packages. And I'm going to pull back a few attributes, and then that'll give me a data frame that I'll be able to view in RStudio. While that's running, let me talk about custom code. This is sort of giving away what I'm going to talk about in a little bit. But if I have a package that I've built myself, like if I have some expense reports package that I've built in R, I can also deploy that without having to set a repo and push it out to my remote SQL server. And I can remove those packages as well. And I need to rename this because I renamed the package in the middle of developing the system. So let me rename that now so that when I check this in and when you grab the code, it won't be too confusing. Okay, here's what we have. Our library paths. We have a lot of things that are installed in MS SQL Server external libraries, and there's some numbers underneath. I wouldn't worry too much about the numbers. I believe that these are language and version values, but I'm not positive. The scope is public, so anybody can load in Broom or Call R or Cell Ranger. And as I scroll down through the list, we eventually get to a point where it changes. Now we have system. So class, cluster, code tools, these were actually installed as part of our SQL Server installation. So the libraries are in a different location. They are system libraries. I didn't install them as part of my work. Incidentally, there are also Python packages that are installed, but I don't see them on here because this will filter out to include only the R stuff. So libraries, the folder location may also be user. User's probably involved in there as well. So it's probably user language version, but again, I don't know exactly how the scheme works. Okay, that was R. Now for Python, I'm going to go a little bit more old school. We're going to come down here to a prompt, and I'll leave the cam on for just a moment. If it starts interfering with the text, I'll turn it off. But, so first thing I want to do, import sqlmlutils, and then mlutils package management scope import scope. So you may ask, well, what if I don't have sqlmlutils installed? Do I have to go, like in R, grab that tar gzip and install it? And the answer is actually no. They actually have a pip installer for sqlmlutils. So you can just go pip install sqlmlutils. It'll install it for Python. Once I have this installed, my next step is going to be to create a connection to my SQL Server instance. And let's do that right here. So I've created a connection to localhost expense reports. And then I have a Python executor that reads from my connection. I have a package manager that reads from my connection. The question was, are you installing RODBC ext from CRAN or IMRAN? The short answer is it doesn't really matter. You can definitely install it from Microsoft's repo, cran.microsoft.com. You can also install it from any other CRAN repo. It just needs a relatively recent version of RODBC ext. So we've loaded a package manager, and once I have that, I can call packagemanager.install. So this will install the Werkzeug package. If it's already installed, I just said, go ahead and upgrade it to the latest version. And make this a publicly scoped process, which means that anybody's going to be able to call this package. So it already said, hey, wait, it's already installed. It's already at the correct version. I don't need to do any extra work. I said, good, you passed the test. Now, you don't have to pass in all the parameters all the time. The bare minimum would be something like packagemanager.install term color. And I've already installed term color. So it says, well, you're trying to install, it's the same version. I'm not going to do anything. But if you really want to, okay, set upgrade to true, and we'll force an upgrade in there. So, reason he's asking is, CRAN says package RODBC extensions was removed from the CRAN repository in February. Oh, okay. So I'm using, in this case, I was using cran.microsoft.com, which I believe for my version of SQL Server is snapshotted to sometime in 2019. So you may have to use that version, but it's there at least. It hasn't been taken off yet. Microsoft has now updated their install page. Oh, cool. So installing new packages for 2019. Yes, this is for using sqlmlutils. I'll review that to see if anything's changed since I created the slides. But it does. This is the process I'd gone through a few times when working with installation of ML services. If I want to install custom packages, then I can install and uninstall using the same functions, and you'll have your own custom package name. Like I have my custom package and a wheel file. Now, I'm not going to create a custom package in Python tonight. That was one of the things that I didn't have enough time to finish up, so I instead have a version in Python that shows why I really recommend creating packages. So sort of treat that as the opposite side. The what not to do. Okay. Let's talk about executing external scripts. We've installed packages. We now want to do something with them. And the way to do that is to run a command called sp execute external script. This is a stored procedure, system stored procedure, that takes in a few parameters and instigates the call out to the launchpad and the shelling out to R or Python. The process is really simple. This is as simple as it needs to be. Execute external script, set a language, set a script. So language equals R, script is print hello world, and that will print hello world out to the console. If you want to do it in Python, it looks like this. So now that we are R and Python experts, we can continue along. RODBC extension deprecated. It was fixed 8 days ago. Okay, thanks for the update. I will check that out and update the sqlmlutils for R notes. Appreciate that. Execute external script for a slightly more complex scenario. Language is R. Here's my script. It's a remote command. And I'll send in some input data. So give me some columns from some table. And I'll call that training data. What this does is it will create a data frame in R that will be constituted from the results of running this query. And it will basically create that data frame. You can do whatever you want inside remote command. Remote command here is now a variable. So this is just a string that represents whatever R command we're going to run. So we can take it, we could maybe split, train, test, evaluate, find a good model, fit the best model, tune hyperparameters, do all the stuff that we need to do, and return back a trained model. So our trained model here will be var binary max. So it'll be a binary output, and this is an output variable. Parameters here can be input or output. If this was an input, it would just look like the highlighted bit. But because I want to return trained model, I say this is an output. And for everything that is in parameters here, I need to have a separate item that represents, well, what is trained model in the real world. So we'll see an example of that in the demos. And here are my notes in case any of that was, in case you go back to this afterwards and want to remember what I was talking about. So we want to build a project. Now maybe this is a little backwards in terms of how we would develop this. That's all that. It's like those times you know how to do something in Azure, then they change the interface. Yes, yes. Those are called Tuesdays. And today's a Tuesday. That's how it works. So building a project. We're kind of doing this backwards because normally when I have a project, I'm going to probably focus mostly on the SQL Server side, showing you some of the basics of that, and then move to R or to Python. But I'm going to show you some of the R code first, and then we'll come to SQL Server and learn a bit more about the project. So here's our problem. We have an organization, and there was some expense report fraud. We know that this fraud happened. We actually figured out who did it. Employees were allowed to submit expense reports up to $40 without a receipt. But if you had an expense report above $40, you had to include a receipt. So several employees started submitting fraudulent claims under $40. Incidentally, this really does happen. And usually the number is much lower than 40. Usually it'd be like $10, where it's not even worth the time. If you submit a $10 claim and you only spent $3, it's really not worth the company's time even to review the receipts at $10. At least historically. Tax laws have changed since. But anyhow, back to the story. So management wants to figure out how much the employees probably took above and beyond expected amounts. We don't know exactly because, again, they never had to send receipts. So we have no way of confirming absolutely what those numbers really were. So instead, we want to try to come up with a reasonable estimation to see what the level of loss was for the organization. So here's how we're going to do it. First thing is we'll hop into Azure Data Studio, and we're going to look at some expense report data. So I have a database called Expense Reports, and I'll share a backup that you'll be able to pull in. I'm actually working on getting this into a Docker container. I've got everything containerized, but the installation of packages using sqlmlutils was not working last night. So I kind of gave up on that and am currently using a backup, and we'll say use that backup until I get the container fixed. But as far as running these queries, it won't matter. It's just the location you point to when you run the query. So we have a table called Expense Report. The Expense Report table includes all of our expense reports. The calendar table is date dimension. It has one row per day and lets us do cool things like say, what is the calendar year? We're going to get the calendar year, the number of expense reports, the total amount of expense reports, and the mean amount. Because medians in SQL Server are a royal pain. So here's what we have on a year-to-year basis. And if I look at this, we have numbers bouncing like 50, 53. We range somewhere 50 to 54. There doesn't seem to be any rhyme or reason. It's at least looking at this at a really high level. Nothing too crazy stands out. But I'm going to join in expense category. And my expense category is broken out into 3 categories. Inexpensive cities, moderately expensive cities, and expensive cities. This was a simplification for me, an extreme simplification to make understanding the problem a lot easier. In reality, forensic problems are nowhere near this easy, sadly. But watch what happens. Our mean for inexpensive cities is like $23, $24, but then in 2017 it jumps up. For moderately expensive cities, it's like $38, $30, $42. For expensive cities, $90, whatever. If you don't want to see those numbers, let's visualize it. I'm going to use the Sand Dance extension if it works. It was actually working when I ran through the demos earlier today, so let's restart Azure Data Studio because it probably got shy now that people are watching it and said that it was a little scared, didn't want to do what I wanted it to do. Oh, the server got shy. Oh, okay. It's up. So we go through, we visualize, pop-up sand dance. This is not the best way of visualizing it in the world, but it is fast enough at least. So my x-axis, I'm going to say calendar year. My y-axis will be the mean. Colors will be expense categories. And let's shrink this down just a little bit so that we can see the chart. So blue kind of bounces around. Green, it looks pretty flat. Yellow, we see a bump. We do see the bump here. That's obviously not conclusive of anything, but we did take some people, put them in under bright lights, and they confessed to their crimes. So we have the bump. And management's like, I think the problem is in this bump. So what's the difference there? How much money do we think that we lost out of this? And that's what we're going to try to solve. We're going to apply some machine learning techniques very poorly so that we can try to come up with a reasonable estimation of how much they've lost. To do that, we'll build an R project with RStudio and appropriate version of R tools installed. It's pretty easy. File, new project, new directory, R package. You'll see something like this. We'll add in our files and we'll create a new project. Or if you're just doing this from scratch, simply create a new project and start creating files. After we're done, we'll go to the Build tab, build a binary package. That'll give us a version of our package that we can deploy using sqlmlutils. Obviously, you can make this part of a pipeline using other packages in R, but like packrat, but I'm not going to show that tonight. This isn't R end-to-end continuous deployment, sadly. So Python side, file new project in PyCharm. I can then create a new Python package. I can write my code. I can generate a wheel file and then ship that wheel file out to my ML services instance as well. Again, I didn't do that for this demo. So let's check out our demo of R. So here we are. I actually have the R project open up right now. And I have two files in here, training models and generating predictions. The train model script is obviously there's not too much going on. This is not my way of saying this is the best way to write a machine learning process, because I'm doing no splitting of training and testing data. I'm doing no evaluation. I'm just basically saying, you want a model? I'll give you a model. So we have a function called train model. It'll take in an input data set, and it'll take in a model type. So this is a data frame. The shape of this data frame will be defined by SQL Server. And that's where I was saying that this feels a little backwards to describe it this way, but I think this is probably the better way to describe things, rather than start out with the bad version and then start to refactor it into an R project. Let's just start with the R project. So we have an input data set, and we have a string that represents the model type. And I'm saying it must be either linear or XGBoost. Those are the only two algorithms that I'm going to support in this process. We're using RevoScalar, and I will take in your string of model type, make sure it's lowercase, check it against whatever I have, linear or XGBoost. If you send me neither, I will actually spit back an error and say, you've got to give me either linear or XGBoost. If it's linear, we're going to call train linear model. If it's XGBoost, we'll train boosted gradient decision or gradient boosted decision tree. So train linear. Given an input data set, we will call rxlinmod and say, I believe that the amount is a function of the expense year and the expense category of whatever expense data is sent in. So actually, I have to double check that this actually works, because it should be input data set. The package works, but I probably built a different version of the package back when I called it expense data. So, yep, So I'm going to change these as well. There we go. So, all right, create a linear model and return the model. For XGBoost, we're going to load XGBoost in data table. I'm assuming that they're installed already. We're going to set the amount as our label, and our data will be the combination of expense year and expense category ID. For XGBoost, we'll call that function. Here's our data, here's our label. We'll go to a maximum of 4 levels deep, 6 rounds of iterations, and our objective is a squared error. So that's what we're trying to minimize here, the squared error. In both cases, I get back model, and then I'm going to serialize that model as raw. So I'm going to binary serialize it, call that trained model, and return trained model to ML services. Now, we're going to store that model in SQL Server, and when it comes time to generate predictions, we'll have an input data set to generate predictions against. We'll have the model type that we want to generate, and we'll have a binary serialized model that we'll use for predictions. So again, we'll do a check on model type. You can, of course, make a model that is a little bit more complex, that is a wrapper that includes things like what is the type of model that it is, what is the class of this model, and then check that class to see what function you should call. I made this really, really simple. So if model type is linear, we generate linear predictions. Otherwise, XGBoost, we generate XGBoost predictions. Otherwise, throw an error because something weird happened. So let's say we generate linear predictions. We're going to unserialize that model, turn it back into a model that we can call RxPredict on. So this is the RevoScaleR version of the predict function in R that is used for the RevoScaleR functions like RxLinMod and RxBtrees, etc. So given our new input data set, what we want to predict, and our model, we will get a set of predictions. With gradient boosted decision trees, we're going to deserialize using the unserialized function. We're going to convert our data to a matrix because that is necessary for prediction. So we have to turn expense years and expense categories into a matrix and build our predictions from there. We get our predictions, and then we're going to column bind the input data set with the predictions. So I'll have all of the input data elements, plus I'll have the prediction. And if I want to, let me go no cam for a moment. I'll go to more, build binary package. This gives me a warning, but it does build the package for me. And then, camera time again, sqlmlutils, I can say, remove packages. So if I have expense reports R, let's get rid of that. And then install packages for expense reports R. So I'll be able to remove, install, and go with this as it is now. So that is our R package. When I have a package, I have the deploying of custom code. So we already saw that. And I'm going to pop over to SQL Server. For SQL Server, we're saying, let's use expense reports. I'm going to have to connect again. So we'll connect to expense reports. And if I don't have a model table, we're going to create one. I should already have a model table, but we'll just in case. Here's where I want to store models. This is a little weird for people in the SQL Server world because historically, if you see a var binary max, you're like, where did this person screw up in life? And usually I'll agree with that. You don't typically want to store a lot of binary data in a database like SQL Server. But models are a little different. And it's mostly a convenience factor because figure it this way. There are a few places where you can put a trained model. One is that you can put it into the package itself. And I do that sometimes. For very large models, I'll just put it into the package. 2 is you can put it into the database. 3 is you could put it onto a file system Well, if you put it onto the file system, machine learning services by default doesn't have access to the file system outside of a temp folder that gets created every time you generate a new session. So that means it can't reach your files unless you go out and explicitly grant access to these accounts. But if you put it into the database, it can just get the model. You could also have it live on a web service somewhere, but now I'm building a new web service just to give me a model that I could simply pass in the function or in a stored procedure call. So I understand if you're a database administrator and you're cringing at this, that's fair. It's fair, but this is actually usually the best choice. And whether or not this is native scored. For today's demos, I'm not showing you a native scored model, but I do like to track whether these are. Rick mentions, usually when you see var binary max, you wonder, where did I go wrong in life? Yep, it sounds like something I would say. All right, so let's create or alter a procedure, train model ML. I like to have at least two procedures. One of them is the external procedure. That is the one that outside resources will call. That is the one that will say delete data from tables, insert data into tables, the modifying procedure. Inside, I like to have an idempotent ML procedure or an R or Python procedure. So if this was an R library that I was calling, I'd probably call it train model R, train model Python, or train model Py. But because I'm going to use both, train model ML. You give me a language, you give me a model type, I will give you back a trained model. This doesn't write to a table. This doesn't delete from a table. This is something that I can run and rerun and run in test mode. I like doing that because sometimes debugging machine learning services scripts can be a royal pain because you can't simply attach a debugger. It's not that easy. And you may find difficulties where I don't necessarily want to write to a system, especially because I think I'm getting bad results. I just want to see what the results look like and be able to work with that. So that's why I like to have these procedures be separate so that I can call them independently of the thing that actually does the system modification, the state changes. So we have a SQL variable and a remote command variable. My SQL statement is going to query some data from expense report. So this looks very much like the information in our original queries, but let me pull this out. And, thought I could do find all. There we go. Okay. So what we're doing is from expense report, join to expense category, join to employee, for expense dates prior to January 1st of 2017. We're going to get the employee ID and name, the expense category data, the expense date, the year of expenses, and the amount. Python doesn't support decimal amounts. It only supports float values. In this case, that's not going to be the worst thing in the world because I don't need incredible precision, but knowing that it won't support decimal, this kind of sucks when you're dealing with money. But we got to live with it. So we have every expense report from every person in our data set prior to the year 2017. And we know that through 2016, people were all living clean. Nobody was cheating the system. So we could build up a history of how they've behaved over time. And by including the year, I can kind of track changes in behavior over time. That maybe as inflation increases, the amounts bump up just a little bit every year. So I can build that factor in. So that's my SQL statement. That is the result set that I'm going to pass into R or to Python. Now my remote command, if the language is R, I'm going to call the expense reports R package and run expense reports R's trained model, sending in my expense data input data set and this brace 0. This is a little moniker I use to say, okay, replace that with the model type. So I like to do this because usually I'll have 2, 3, 4 substitutions. I'd rather have all the substitutions afterwards and simply have a set of inputs here that's like, this is obvious that I'm substituting, as opposed to, okay, well, I'm going to break and then say plus model type. And also, if this is null, that can be a problem. So I'd rather just have it look like this, be one continuous string, and then do my replaces after. If my language is not R, my language is Python. So I'm going to run a Python command. Import pickle, import the random forest regressor, create CLF, which is a random forest regressor. Technically, CLF is typically used for classifiers, but we're going to live with it today. And fit CLF on expense data category ID and year, giving back expense data amount as the label. We're going to fit this. We're going to get the values, ravel them up, and we're going to create a binary output using pickle dumps. So that'll give me back my trained model. So that's a remote command for Python. Because I only have one type of model that I'll train in Python, I don't have any substitutions here. And I don't have any checks of, well, if the model type is this, go for it. All right. So RF, yeah, I know it would be RF instead of CLF. You know what? We're gonna roll this. Yeah, we're gonna roll with this. We'll do it live. There, I'll even save it. That way, when I check in the code again, it'll be regressor instead of classifier. So regardless of which language I'm using, I'm going to call spexecute external script, pass in that language, pass in the script, which is remote command. My input data will be SQL, the result of that SQL query that I created in text. The input data name, I'll call it expense data. That's why I'm able to reference expense data in these functions. And incidentally, it's probably why I was able to reference expense data in the R code, even though it should have failed because I should have been using input data set. So that's the magic of R, where I have access to those data frames, even within a function where, you know, technically maybe you shouldn't, but it's okay. We'll fix that. We'll fix it in post-production. All right. My output, I want to get back a trained model. You notice that we're getting back a trained model here. We got it back a trained model here. So I want to get that as my output variable and return it. So let's run this thing. And at this point, I could, I actually will. Let's do the Python version. Okay. We're going to do a quick test. Train model ML, language is Python, model type is random forest regression. We're going to say go for that. So let me double check, and I need a trained model as the output. So what I'll do is declare as a var binary max, and I need to say there we go. We're going to print the trained model. Oh. So actually, this is fair. I use trained model without an underscore. And then I'm actually doing this on purpose. Trained model without an underscore, trained model with an underscore. Just to tell you that this does not need to be the same as this. So I am doing it on purpose. And then I'm doing it on purpose the reverse way because that's why. So we run this, and it's going to call out to Python. It's going to perform the regression. It's going to give me back a nice hefty string. And it took 8 seconds. Took 8 seconds to do. That's not fast. Like I said, there's some spin up time, and this is not intended for absolute, immediate, needs to be as fast as possible type of work. But it gave me back a result, so I'm pretty happy with that. The train model, this is where we do some real work. So I call train model ML, and I get back my trained model as an output, and then I'll insert that into a model table. So let's truncate that model table just in case. And I will execute train model for R linear, R XGBoost, and Python random forest regression. This will probably take about 30 seconds. So if you have any questions throughout this, this is probably a really good time to ask questions. Actually, 10 seconds ago was a really good time to ask questions. This is now an adequate time. Okay. Pickle, yay. Yeah, that's fair. If you generalize it, at least from sklearn, it's red, not RF, random forest specific. RF is okay. That is perfectly reasonable. Although I could say that I'm using this to confuse my enemies, so that they don't know what model I'm using. Looks like we got our outputs. Everything worked fine. And we get our model outputs. Linear, XGBoost, random forest, they're saved in the database. If you're interested in how long these models are, how big these things are, 14K, 30K, larger models I've seen could be a few megabytes. If you have something that's that big, I would actually recommend that you gzip compress. And gzip compression for things like random forest models work really well. So what we typically would do is say, if the model type is one of these that compress really well, go ahead and compress it. And then in the stored procedure to use the model, we'll decompress it afterwards. So Mike mentions, I know you said you don't have time to address security concerns using R and Python from SQL Server, but the pickling and packaging of R and Python does not allow inspection from the SQL Server side. So what privilege is provided to the R or Python code? Very briefly, the R and Python code by default with a brand new installation of ML services cannot access the internet, cannot access the file system except for the local file. Or excuse me, the local directory, a temp directory that is created just for that particular execution. So they can access files within a folder that is a temp folder just for that execution. So you could still write out to there and read from there, but you can't read from anything else in the file system. You can't read from the internet. It is sandboxed. You were correct. So yeah, that is a change from SQL Server 2016 and 2017, where there were more rights. They locked it down quite a bit with application containers in 2019. So it's a lot tougher to do much with R and Python code unless you explicitly grant rights. Is it the Launchpad service that is initiating the execution? The Launchpad service is going to call out to rterm or to python.exe. Technically, if you want to go really technical, it's within SQL Server that is initially contacting the Launchpad to tell it to go call out to R or Python, but yeah. Any noted CVE privilege escalations? Not that I'm aware of. I don't know of any CVEs related to machine learning services. Okay, so we have models. We have gone so far as to save, make some changes, create some models. I'm going to save that script because those were some nice updates. I appreciate the code review on going with Reg. So now we're going to generate some predictions. Any external access from R or Python executables would be in the security context of the Launchpad service account. Not quite. It is in an application container that, yes, does use the Launchpad security account as sort of its base, but can be restricted further from there or can be extended further. It is a separate account for essentially the app container. So once again, connect to expense reports. We are going to create or alter, generate predictions, ML. So Big Mike and Austin mentions in 2017 using Python to read CSV files, not needing to do anything special for read permissions. You are correct. In 2017, the permissions were different. And you had the ability to read from disk, to read basically from anywhere, and to write to disk. But 2019 changed that model. You can still grant the rights. If you say you have access, the app container service, the app container account is allowed to read and write to this directory on the file system, you can still do that. But you have to be explicit in granting those rights. It's not by default anymore. Could it be the caller Windows account of SP execute external script in SQL Server? No, that is not going to be the case. It'll be the app container account. So can you specify which user you become? No, it is the app container account. Invoked function, it's just the app container account. It has nothing to do with who's calling it. As long as you have the permission to execute an external script, that app container is the authorized account that is shelling out to our term. Because users and logins in SQL Server are in SQL Server. They're not going to go to the Launchpad. There's a service separation here. And the Launchpad service is involved in getting to the app container. All right. Generate predictions ML. Language and model type. So I have a language, I have a model type, I know what they are in the database, and I'm going to now generate predictions for everything after 2017, when the fraud began. So my SQL statement is the same, except that I changed the expense date. Whoops. That went a little too far. My model process is to say, from the model table, given a language and a model type, and we're not using native scoring today, get me the trained model. Then, if my language is R, I'm going to load up expense reports R and generate predictions using the data from that from expense data for that trained model. And we'll replace model type in here. If you're using Python, we import pickle and pandas. Pickle, we're going to load the trained model so that we have a model object. And we're going to convert that into a pandas data frame where we have the amount prediction, which is model.predict given expense data's expense category ID and year. And the output data set is the concatenation of my expense data and pred. It's basically the equivalent of cbind for Python. Okay. So we'll execute external scripts. This looks very similar, except now instead of this being an output parameter, it is an input parameter. And also, I decided not to switch this to trained model. I will probably add a note to say that that was intentional in the stored procedures, and I don't recommend that you arbitrarily change how you specify names. But that I was just showing you is for andragogical purposes. Here's another thing. If I'm spitting out a result set, I will need to include with result sets. That includes all of the columns and data types that I will use. So amount here is a decimal 5,2. Andragogical is like pedagogical, but for adults. Pedagogical is technically for children. Amount prediction is a float because Python works in floats. The amount wasn't actually used in Python. It wasn't sent in. We only sent in the expense category ID and expense year. So it's kind of interesting. The columns that are the values that are not used actually don't get sent to Python or to R. It's only when they're used that they get sent. So I'm assuming that you are adults. Well, due to COPPA, I'm assuming that everybody here is at least 13 years of age. You're all you definitely look at least 18 to me. All right. We have this result set. We're spitting out outputs, and we have some values that we want to get back. A fun thing, if you want to insert data into a temp table or into some real table, you don't need with result sets because the shape of the table has to be exactly the same. But if you're just returning this, you do need with result sets. So because I'm just returning it, I need with result sets and I need to specify. So I run that. Now, I could do a test of this just to show you what the results look like, but I'd rather show you the end product. We're going to load it into a temp table, predictions, and the predictions has roughly the same shape. I did make them out in a float. Insert into predictions, executing this, generate predictions ML. And then we're going to query this data. Now, this query may look a little scary at first, but we're going to walk through it piece by piece, so it'll be easy. From predictions, one of my favorite uses of the apply operator is to simplify calculations. What I'm doing in here is I'm saying cast amount as decimal, cast amount prediction as decimal, because I hate working with floats. I want to switch this back to decimal. It's not ideal. The ideal here would actually be if I could work in decimals the whole time. And with R I can, with Python I cannot. So I'm going to work in floats, I'm going to bring it back to decimal, I'm going to pretend that any sort of imprecision didn't happen. Let's just plug our ears and hum really loud. But it does let me show off the cross-apply operator, so that instead of saying cast p amount as decimal in here, and in here, and in here, and in here, I can do it once. I can call that amount. I alias this as C, and I can say C.amount. And that represents that operation. So I have amount as total, amount predicted as total predicted. So I'm summing those up by person and by category. And I want to get the mean absolute error and the mean absolute percent error. Python had infinite precision decimal. Why does SQL Server not allow its use? I don't know the answer to that. If you try to use a decimal type in ML services for Python, it will give you an error, and it will show you the types that are allowed, which includes float, but does not include decimal. There's probably some issue that they had in the translation that I'm not aware of, but them's the breaks. So I'm calculating MAE and MAPE. I'm going to group it by employee name and category, order by employee name and category. So we will work with this procedure. And now things get fun. I'm going to start this out with XGBoost. So we execute the procedure in our XGBoost. It's going to give me back some predictions. It's going to give me back my how close I was on average in terms of dollars off. It's going to give me back my percentage in actual percent, how far off I was on average. So for example, for Barrett Bonden in expensive cities, there were 74 expense reports. We predicted 5,800. It was actually 6,900. So on average, it's about $14 off, and with a MAPE of 15% error. If I scroll through these are consistently at least 10, 11, 15%. This is 46% off. I mean, this looks bad, but here's the problem. Everything's bad. The way I configured XGBoost, we'll say that I did it on purpose because I don't want to show perfect models. This is a reason why you evaluate. This is a reason why you have known results, because you'll end up in cases where, yeah, you're way off. You're always way off. I don't think I can trust this model. So let's try the linear model. The linear model is going to come back with something that's a lot better. It'll end up being 4%, -3%. So we're in single digit percentages. It's still a few dollars off, but not too bad. And I can look at this and say, all right, I can see what's going on. You're usually pretty close. Oh my gosh, 39%. But here's the thing. He's one of the cheats. We know that he's a cheat. And we know that he was cheating on things under $40. So our model predicted, by the way, that for expensive stuff, our model was within 15 cents on him. For inexpensive stuff, it's $15 off, because he started putting in near $40 expense reports constantly. Of course, it's Ebenezer. Yeah. Look, Ebenezer Graham, I don't think I can trust this guy. As we go down, Emily Sweeting is fine, Jack Aubrey's fine, Molly Hart is not fine. So Molly's also a cheat. And we have Nathaniel Martin, same concept. So where we're seeing this MAPE of 30% off, about $15 off, these were the people who were cheating. And I could join back to the table and find out that, yeah, those were the people we busted. What was also interesting that we had difficulty seeing in the initial high-level look is they were also cheating on moderately expensive reports. So if I go back to the basic research and visualize those moderate values, it's hard to tell, but there is actually a little bump right here. So remember, everything under $40 was going to be a no report required thing. So essentially, sometimes you could go to a moderate city and spend $25. And in those cases, they'd bump it up to near 40. So on net, it may not have been that many cases, because we can see that in predictions, it's only going up by a few dollars. But by contrast, somebody who was not cheating, let's go find someone of impressive moral character like William Mowat, where we're within $1 in both of these cases. So this is a person who was not cheating. In the moderately expensive, we're within $1. Stephen Maturin, another person of impeccable character, within $1.25 versus $4 for somebody who was cheating. So we can see these differences. And we can say, oh, well, our predictions are reasonably decent, because for the people who weren't cheating, we were pretty close. And so we could say, what were the predictions, sum those up, and get an idea of what the difference was for inexpensive and moderately expensive cities for those people who cheated, and say this is probably the upper end of how much fraud there was. And by the way, the Python version of this, just to show that it's not a language thing, the Python version also works really well for random forest regression. MAE is a little higher. Percentages are a little higher. But we easily catch the ones who are cheating. And the percentages actually are pretty close in terms of who was cheating and how far off we were. So we're able to track that. Now, I could make this as part of an ongoing process, as I'll run predictions for new expense reports and see how do things look this week? Do people look like they're still putting in expense reports that are too high? Maybe this example is sort of a forensic example, is more of a post hoc analysis than an ongoing process. But one place where we do use machine learning services very heavily is in forecasting demand of products. So I want to know, well, what's the demand going to look like over the next 30 days? And that way, that's a question that I always have, regardless of how many times I've made the prediction. Of course, I want to know the next 30 days as well. So that's a case where machine learning services really fits, because we're going to create ongoing operations, ongoing predictions, store those ongoing predictions, and cycle them through as we get to the point where we've reached the end of the prediction period. It's time to create new predictions. All right, so wrapping up, SQL Server Machine Learning Services is going to give us the ability to operationalize R and Python code, give us a way of bringing machine learning models to production. If you want to learn more about this, I do have the link up already. It is csmore.info/on/mlservicesdev. So let me drop this link into chat in case you want to play around. Probably wait until later tonight when I upload the latest version of the commits that include the stuff that I was doing tonight. It's what happens when this is the first time I give a talk. Weird stuff comes up. If you have any questions at all afterwards, feel free to hit me up, email, or Twitter. And with that, if there are questions or comments in chat, let's talk through them. So the problem's root cause, not requiring receipts on every expense report with random spot checks to remove its business cost. Yeah, actually, so in reality, if you care about that sort of thing, let's say we go back 30 years in the past when tax laws were a little different and you didn't have to have receipts for every single purchase. In that case, you would still probably want to do random audits. Or you just say, we're going to accept that this is the per diem that we're going to give employees, and it's $10 a day. And for people who constantly submit $10, it's not that big of a deal for us. We have already expected that you will submit $10. If you submit $6, then it's kind of a windfall for us. So if you're willing to look at it that way, it's not a big deal. I made it $40 just so that I could have a more extreme example. The example that this originally came from actually was fraudulent bus. So it was Wake County Transportation, Wake County, North Carolina. There's transportation division for the schools. And there was some fraud going on with county employees and a particular auto parts company that were generating a bunch of fraudulent invoices. And in that case, the minimum was $1,000, where any invoice up to $1,000 only needed one person to sign off on it. Any invoice above $1,000 needed two people to sign off on it. So the group would submit dozens of fraudulent invoices under $1,000, and they'd all get paid out. The county employees and the company would split the money and go off and essentially cheat taxpayers. It took years to figure out that this was happening because nobody was auditing the system. There was some external auditor who ended up coming in looking at this, and you could see with a simple regression just how extreme the amount of fraud was in real life. I have a whole talk that uses that as a baseline for an example. So it was an interesting thing. It was about 15 years ago when that happened. Any real world guess how well you could detect the people and amount of cheating just with statistical ML? Yeah, absolutely. I just walked through the example there. So the information was in a PDF that I think has been lost to the sands of time, but in that case, that was several $1 million over the course of a couple years. If it's large amounts of cheating, you're going to catch it fairly easily. The problem is that when you have a huge number of variables, and a lot of noise, you can cheat within bounds and it gets tougher. There are still ways to detect tampering. That's where you get into things like Benford's Law. And if you're really, really interested in all of this, then let me give you the link to the presentation that I have on forensic accounting techniques. because there you go. That walks through, like I said, it walks through an actual example. You can read some of the info. WRAL still has some of the reports up on their website, but it was not trivial finding them. Although, ironically enough, this was actually a case where they were so blatant about it that you could tell in a regression line. So let me pull that link up because I want to show one slide from it. That one slide was a report that the auditing company put out later on. Where is it at? Here it is. So the auditing company put this out. This was not me. And what you see is they said it was basically a linear regression. I actually would argue that it's not quite linear, that it's closer to I don't know, log linear almost, because there are economies of scale. But regardless of which model you pick, when you're this far off, you're talking several $1 million a year off, you got problems. And that's what they found out. All right. Crooks are outliers, either stupid or smart. I have no comment on that. Although this is an interesting area. Actually, I like forensic accounting a lot. Which, yeah, I'll just leave it at that. I like forensic accounting a lot. It was an interesting topic for me. Okay, so question for the end. I tried this when it went GA in 2016 and found it frustrating to get it set up and working. Is it easier to set up today in 2019? I believe the answer to that is yes. Several bug fixes have happened since then. Several bug fixes that I had have been fixed. It's still not incredibly trivial. There are a lot of intricacies where things will seem like they fall apart. And it's hard to explain why. Where you can run the code in R term or you can run the code in Python console and it'll work perfectly. And then you try to run this in machine learning services and it'll fail for a weird reason. Some of those weird reasons are things like memory allocation. And that was yesterday's shop talk where I talked about resource governor. You may find other things like versions of packages. Upgrading packages, base packages in R and Python with machine learning services is a royal pain. So that's an issue. You can bind a new version of machine learning server, but now you're dependent on waiting for Microsoft to come out with that version. If you just want to piecemeal update the version of Python from 3.7 to 3.8, they don't really support that directly, and it can bork your system. So something to keep in mind. You're probably going to end up working with stable, by which I mean old, versions of R and Python. So if I have time at the end, can I address security concerns around ML services? Government and some industries may not like having it installed. So can we speak to what we can do to convince them to reduce concerns around security? I kind of danced around a little bit with the 2019 changes with application containers. This is why they made those changes, because there were several clients who said, we like the idea of ML services, but I can't get that installed on my SQL servers because it allows arbitrary R and Python code, and I can't get that past my security team. So that's where they put in app containers, sandboxing you down to running local code, hitting local drives, hitting a local temp folder, and not having access to the outside world unless explicitly granted. Now, it makes it harder for you to install something like Keras, because Keras expects to be able to write to different places. You're like, oh, you can't do that anymore. It makes it harder to read models from disk or to read files from disk, because again, you have to know where they're at. You have to explicitly grant those rights. So Solomon mentions that there's no true decimal type in R, which is true, and Python doesn't have it built in, but the standard library includes additional numeric types like capital D decimal. for floating point numbers with user definable precision. So yeah, that probably explains not being able to use decimal as a type. With R, you still have the numeric. There is actually a decimal L, which is no, L is long. There is a proper decimal type in R that I'm blanking on at the moment because I got a camera pointed in my face. But yeah, in general, there's probably some just incompatibility between data types that they had to say, well, we can't use this. In R, they tried to do their best. In Python, you get a hard error. In what cases do you actually make the recommendation for ML services on SQL Server versus ML as a service using something like Azure ML or H2O or DataIQ or whatever? For that, I would go back to a much earlier slide and say, I want you to have at least one or two of these things be true. And if you have one or two of those things be true, especially if you have 1, 2, and 3, that's a really good argument for using ML services. Now, there are downsides to it. There is extra cost because essentially you're basically saying, I can do my machine learning work in SQL Server where I pay $32,000 per core for enterprise licensing, or I could do it in a VM where I pay several dollars per core for licensing. And you look at those numbers and you're like, that doesn't make fiscal sense. But this is where we can get a little trickier, because what my team will do is, especially with that demand forecasting model, the large neural network model that we include in the library, all of that training happens outside of SQL Server. So we train on machines with GPUs that are special built for training data. We train, we build our model, we package that model, we deploy the packaged model to SQL Server, and then we generate predictions from SQL Server. Now, within that demand forecasting solution, we will train models within SQL Server for some cases. If you fit with that aggregate neural network model, we're going to use it, and then we don't have to train anything special. If you have a certain sales pattern, we have an aggregate random forest model that uses native scoring. We can dump a bunch of products in there and save a huge amount of time. But if you don't fit with either of those, we're going to train a custom model, and that will happen on SQL Server. That's because we decided we're going to dedicate those resources and essentially put that effort into being on the server itself, rather than having a more complex process which basically shells out requests for training separately. We have the data living on that machine. We don't care about how long it takes. Practically, if it's 5 seconds versus 20 seconds, I don't really care, because that machine is specifically for machine learning operations. And sometimes we can use native scoring. So those are the scenarios where I would say that's when you really want to use ML services. And sorry, Mike, the bot apparently did not like what you said. This is a very aggressive bot. I will probably turn down the bot's aggressiveness, because I'm pretty sure you didn't mean to do anything bad. It's just that the bot is a very angry bot. Has anyone come to you and asked you to compare with other SQL options like Teradata, Vantage, or Postgres Python extensions? What is Microsoft's biggest competitive advantage here? I want to be mean and say, wait, Teradata's still a company? But that's being mean. I like Teradata. I went to school near Teradata. Or at least where they used to be before they left Ohio. So, I'm not that familiar with Vantage. Using Python in Postgres I don't know how much machine learning happens with Postgres Python. I always thought that that was more of you can write stored procedures in Postgres in any language, anything from C to Python to their version, their PSQL. But you could, I'm sure that you could also use a lot of the same techniques and generate a model. I guess the advantage here that Microsoft has is that execute external scripts interface and the ability to say, within here, you are working in a sandbox. You're limited in what you're allowed to do. So for operations, for those larger customers where security is a major concern, it is going to be an easier sell than let me run any Python script within code. But again, I have not dealt with Python on Postgres, so I don't know how they work with security. I don't know how they work with integration. If they do an awesome job, great. That's cool. I don't get paid by Microsoft, so I want companies to do good things because maybe that'll spur Microsoft to do good things too. Okay, now you want to harm the bot. I mean, the bot's just doing its job. The bot's job is to arbitrarily time people out and to take advantage of its timeout abilities. So unfortunately, yes, it does remove all your prior messages. If you have Better Twitch TV, the plugin, then you could end up seeing those messages that were timed out. It is really aggressive. I am going to tone it back just a little bit. So next time around, the bot will be not quite as aggressive. I also noticed that on Data Architecture Day, where with emotes, it kind of kicked people out, even though it probably shouldn't have. But we'll tone it back. We'll make the bot a little friendlier. Really, I want to keep. The reason I have the bot in there is so that if there is somebody who comes in and spams, I want the bot to be able to catch it rather than forcing me to do it. Microsoft should pay you. Then I'd have to work for Microsoft, and I don't want to do that. Okay, are there any other questions or thoughts that anybody has before we kick it out? And while you're typing those out, I want to drop in those links at the beginning. RTA, join their group. Check out Analytics Forward. Whenever that will be. That is always a great conference. Their Slack channel. There we go. Here is their Slack channel. So you can join their Slack channel and spend time chatting with them. If you want the Data Architecture Day playlist, we're going to put that in right there. So you'll be able to check those videos out at any point in time. Mike points out that Python does have infinite decimal built in. There's probably some difference between the way that SQL Server decimal works and the way that decimal works. So it's, again, I'm sure the developers have an answer. I forget if I've ever asked the question, but they probably have an answer. Is there no or minimal? I gotta wait for the full question, I guess. Security concern with SQL Server. From the development side, I mean, the short answer is you're going to cause more problems than the database engine typically. And with Python and R, I am not aware of any CVEs around machine learning services. That doesn't mean that there are zero security issues, but I'm not aware of any CVEs. Usually problems are going to be more of you messed something up and using dynamic SQL allowed somebody to perform SQL injection or something along those lines. Things were not configured very well. There are occasional remote code exploits. There are occasional vulnerabilities within the engine itself, within the various components themselves. You'll see them every once in a while. Every few months you'll see one pop up. But as far as large complex software goes, it's not that bad. So, all right, it looks like that is all of the questions for tonight. Based on the question about government not wanting it. So the question about government not wanting to use this was because in 2017, this was a design decision that you could perform operations as the service account and by default had the ability to read basically anything on any drive. And that was something that customers did not like so much. There were also things about creating a whole bunch of different Active Directory user accounts that you then had to grant rights to, and it was a little weird to work with. It was sort of their way of trying to parallelize operations within ML services, but those have changed with 2019. So there's code you can't inspect. I mean, depends on what you mean by that, because you install the packages. You're installing that package. If you don't know what's in the package and you care about what's in the package, you have the choice not to install it. For a custom package your developers created, your developers better know what's in that package. For third-party packages that you're installing, if you're in an environment where that is paramount to understand, again, you can decide, I'm not going to install this package unless you show me the code for it. So packages don't automatically install themselves. People have to do that at some point. Okay, with that, we're going to wrap up tonight's sessions. Thank you so much for everybody in attendance. Anybody who's watching this after the fact, definitely appreciate all the great questions and commentary in chat. Absolutely fantastic that we were able to pull this off, get a lot of nice feedback here. And if you do have follow-up questions, like I said, hit me up, email, Twitter, Shop Talk, whenever. With that, we're going to take roughly next week off. And then we'll be back for Shop Talk in the beginning of June. We'll be back for more sessions of the Triangle Area SQL Server Users Group throughout June. We've already got a couple one that I've got on the schedule, a couple more I need to add to the schedule. There will not be a data science subgroup meeting next week. We had our speaker unable to be able to make it, unfortunately, but so I decided, all right, I'm just going to take that week and relax, turn off the camera for a little bit. Occasionally, I do take time off. No Shop Talk next week. So there is no Shop Talk next week. I might do a coding with Kevin at some point. Depends on how things work out. But just start from the assumption that I probably won't do very much next week. So, all right, everybody, thank you so much, and I will catch you next time.